I've been waiting way too long. Yeah, I've been out here trying to get it. Yeah, I've been waiting way too long.
This is the video for slope and rate of change. Slope is the ratio of the change in y versus the change in x in a function. In a linear function, the slope will remain constant, meaning the same, throughout the function. Here we have an example of a table with some data in it, and we're going to look at the rate of change or the slope. So it says the length of a baby as a function of their age in months. So length is the dependent variable, like our y, and age is our independent variable. The length depends on the age. So what we're going to do is we're going to look at the rate of change from each month or each age that they give us and kind of see a pattern maybe here or maybe not. The length in the first two data points is increasing by 4 inches from 23.5 to 27.5, and the age increases by 6 months. So the rate of change there is 4 over 6, which is the same as 2/3. Which, what does that mean? That means for every 2 inches the baby grows, the baby has aged 3 months. So at that point, they're growing 2 inches every 3 months. The next set goes from 27.5 to 31.6, which is 4.1 inches increase, and the time increase is 9 months plus 9. So the ratio here would be 4.1 over 9. The next one goes from 31.6 to 34.5, which is 2.9. And the increase is from 18 to 26, which is 8 months. So that would be 2.9 over 8. And the last one from 34.5 to 36.7 is 2.2. From 26 to 33 months is an increase of 7. So that ratio would be 2.2 over 7. So we have 4 different ratios here. Remember, this is a representation of real data. It's not something that's made up. And so these ratios differ a little bit, and that's normal. So this wouldn't necessarily be a linear function, but we can talk about the rate of change and maybe how it's different in each part of the table. So the rate of change between the first 2 points is 2/3, which is about 0.667. The rate of change in the second 2 data points is 4.1 over 9, which is about 0.456, because the 5 repeats. The next one is 2.9 divided by 8, which is about 0.3625. And the last one is 2.2 divided by 7, which is about 0.314. So we can see what's happening here is that the rate of change is decreasing as the baby gets older, which makes sense. At the beginning, the very beginning, when a baby is very young, they grow a lot in a short period of time. And as they get older, they don't grow as fast. So again, these represent the rate of change. And so the rate of change is not constant. In fact, the rate of change is decreasing. The baby grew the fastest between 3 and 9 months because that number is our greatest value. And the baby grew the slowest from 26 to 33 months because that number is our smallest value. The rate of change represents the speed the baby is growing because, again, it's length per month. It's length in inches per month that they're growing. Now we're going to look at a graph and determine the slope from the graph. So I put this table here so that you could see the points that I plotted, so that you could draw this graph in your notes, which you need to do. So you need to do that before you continue the video and I explain this. So remember, slope is the change in y versus the change in x. So that delta, that triangle, is the Greek letter delta, and we use that in science and math to represent change in. Okay, so change in y over change in x. This is a linear function. How do I know that? Because it's a straight line. That means the slope is the same between any 2 points. So if I go from this point all the way up to this point, what I'm going to do is I'm going to draw a triangle to show the change in y and the change in x. So the change in y is going to be this much, which is 3. The change in x is that much, which is 1, 2, 3, 4, 5, 6. So notice how I write the 3 and the 6 right above those lines that I drew, those segments. So the rate of change is 3 over 6, which I could simplify to 1 over 2. Now watch this. If I go from this point to this point, I'm going up 1 over 2. So again, you can see that that matches my rate of change that I found in between the first 2 points. So if it is a linear function, if it is a straight line, the rate of change, the slope, should be the same no matter what 2 points you picked. You also need to notice here that from left to right, this line is increasing. It's going up. And so this is a positive slope. And you need to know the difference between a positive and a negative slope. I have 2 more examples of graphs here. These are sort of special scenarios. So in example A, I see a horizontal line. So I'm just going to put 2 points here. Okay, that is at y equals 4. Okay, so the equation of this line is y equals 4. We'll talk about that later on in this unit, but not quite yet. But y equals 4, and so I've got these points here. This is the point negative 4, 4, and this is the point negative 7, 4. So when I think about my rise and my run, if I'm trying to get from this point to this point, my rise is 0. Okay, and when I refer to rise, I'm referring to this right here, the distance I'm going up or down. So my rise is 0, my change in y, also called the rise. My run, though, is 1, 2, 3. My run is 3. Okay, again, that's the change in x. So this is change in y, and this is change in x. We also call that rise and run. 0 divided by 3 is 0. So the slope of a horizontal line is 0. And that is because the rise is 0, which is the numerator. Now let's look at example B. Again, I'm just going to pick 2 points and plot them. So I've plotted the points negative 3, 3, and negative 3, negative 1. And so I can see here that the x values are the same. So actually the equation of this line is x equals negative 3, because x is always negative 3 no matter where you are on this line. So now I'm going to do the rise and the run. So from here up there is 1, 2, 3, 4. My rise is 4. My run is 0. I do not have to move left or right to get from one point to the next. So my run is 0. In other words, there is no change in the x. I mentioned the x value is the same. 4 divided by 0 is undefined. You cannot divide 4 things into 0 groups. That is undefined. So the slope of a vertical line is always undefined. So here are the things that we discussed. We discussed slope, which is rate of change. Okay, those are the same thing. We also discussed that it is the change in y over the change in x. And we said that we also can call it rise over run. I want to make sure that you do not get slope confused with an ordered pair. So when I talk about slope, I talk about rise over run, which is change in y over change in x. That is not the same thing as an ordered pair, which is x comma y, which tells me the location of a point. So here are the 4 different types of slope. The first is positive, the second is negative, the third is 0, and the final is undefined. Make sure you have those in your notebook so you can refer to them. The most important thing, in my opinion, when you're looking at a graph is to first determine which of these 4 slopes you are looking at, and that will make solving the rest of it a lot easier.
I've been waiting way too long. Yeah.